Chapter 14, number 29. Two trains on separate tracks move towards each other. Train 1 has a speed of 1.3 times 10 to the second kilometers per hour. Train 2 a speed of 90 kilometers per hour. Train 2 blows its horn, emitting a frequency of 5 times 10 to the second hertz. What is the frequency heard by the engineer on train 1? Okay, so the first thing that I did is I converted my kilometers per hour to meters per second. Always convert first. So the velocity of the observer, I solved for 36.1 meters per second. The velocity of the source, I solved to get 25 meters per second. The frequency of the source, they tell you, is 5 times 10 to the second, or 500 hertz. And we are solving for the frequency of the observer. So both the source and the observer are in motion, which means that we can use the general formula if you choose. You do not have to. Some of you are going to choose to do it using the general formula again. Some of you will choose to memorize the specific cases. Whichever way you do it, totally fine. Because both of these, the source and the observer, are moving towards each other, both the source and the observer's velocities must be greater than 0, so nothing should be negative. Okay, so plugging into our formula using our appropriate units, I solve for 596 hertz. Number 31, an alert physics student stands beside the tracks as a train rolls slowly past. He notes that the frequency of the train whistle is 465 hertz when the train is approaching him and 441 hertz when the train is receding from him. Using these frequencies, he calculates the speed of the train. What value does he find? So this one is a little bit complicated as far as mathematics go, which is why I did put a star next to this. So the train, which I denoted as the velocity sub t, so the velocity of the train, which simply is just the velocity of the source, so you can leave it like that. As it's approaching the stationary observer, which the observer will have a 0 speed, as it's approaching, the train should be positive in terms of its speed. So the first thing that I did is I solved for an equation, or created an equation that allowed me to solve for the train as it's approaching the stationary observer. So that's where this comes from. So the 465 hertz is the speed as the train approaches. As it approaches, the velocity of the train, the velocity of the source is going to be positive. So subtracting the velocity of the positive source, we end up with this equation here. The next thing that I did is I went ahead and I found I substituted in to find an equation as the train moves away. So in this case, if the train moves away, the train will be negative velocity. So the 441 is the receding frequency. Again, the 343 comes from the fact that we're in air. We're moving away, so we have a negative velocity. So subtracting the source that is negative essentially becomes positive, so you have an addition here. What I did was I divided the first and the second equations. This is where the mathematics comes into play. So if you have questions specific to the math as far as why I did something or how the math kind of works out, definitely let me know. In this case, you're able to divide the 343